Alright, this morning we're looking at cubics. And graphing cubics. So we'll look at the different forms of cubics and see what we can get from those. So a cubic function, the highest power is x cubed, and there's some different forms. So if two forms in particular, we could have it written as a perfect cube kind of form. So similar to turning point form in a parabola. It's a perfect cube. So the things that we've got the A, so the A does what, do you think?
Dilation.
Dilation, yep. From the x-axis. If it's negative, what happens?
It's
starts with R.
reflection.
Reflection, yep. Alright, the H does what?
Moves it left to right.
Moves it left to right, yep. And the K?
Up and down.
Yep. Up or down. Now, cubic functions of this form don't have turning points, but what they do have is a thing called a point of inflection. And our point of inflection will be at H and K. And so our normal, standard, everyday garden variety of cubic, so to just the standard x cubed, looks like that there. So we have our point of inflection, which is here. It should actually be a bit flatter than what I have. Gradient 0. Alright, so our normal standard variety cubics will start here, bottom left, finish up here, top right. Alright, so that's one form that we could have a cubic in. The other form that we could have a cubic in is expanded. Like so. Now we need to factorise. To find our intercepts, to find our x-intercepts. Alright, so in other words, if x equals to 0. Now, when we do factorise, there's some certain things that happen. So if we have a linear factor, so an example I might use is, say, x minus a, then a linear factor will do something at the x-axis. Anyone think of what happens at the x-axis with the graph with the linear factor? No one? Does it cut through or does it turn around and go back?
Cuts through.
Yeah, so it cuts through. The axis. If we have a repeated factor, so e.g. x minus b squared plus b squared, let's go plus b squared. That's a repeated factor, and a repeated factor does what at the axis? Turns around, yeah, so it touches the axis. At negative b, and i.e. that means turning point. So if I was to draw, for example, fx equals x minus a times x minus b squared, I would end up with, oops, plus b squared. So if a is there, negative b is there. Now it's a normal standard, hasn't been reflected, so there's no negative out here. So it hasn't been reflected, so it starts the bottom left, so it starts down here, heads up to b. Now b is a repeated factor, squared, so it turns around, comes back, then it's got to get back up to here, goes through there somewhere, and up like so. Alright. Now, these next things, some people like these, some people don't. But there is mention of them, so we need to make sure we cover them. And that's things called a sign diagram. And all a sign diagram indicates is whether a function is positive or negative in a certain section. So So here's an example of a sign diagram. So a sign diagram would have a line, then it will have some sort of scale on that line. And I haven't put all the numbers, but on that scale that I've got here, these would be our x-intercepts, if you like. So for this particular graph, it intersects the x-axis at -2, 1 and 3. Then up here is positive, so i.e. the graph's above the x-axis. Down here it's negative. So if you have something like this, tells you that from negative infinity up to -2, the graph's below the x-axis. And then we go there. Now sometimes you might see them joined up here, sometimes not, doesn't really matter which way they are. And then this one goes back negative there, and it comes back positive there. So all it tells you is your line below the x-axis or is it above the x-axis? That's all it tells you. So for this particular function then, fx, the function fx, it's greater than 0 here and here. So when we've got between -2 and 1, union with 3 to infinity, that's when it's above. It's negative, or less than 0, from negative infinity to -2, and then between 1 and 3, and it's equal to 0 when x is equal to, and so when it's equal to 0, i.e. x-intercepts, at -2 and 1 and 3. So if we were going to draw that particular function, if we drew it, it would look like this. So we've got -2, I'll do a bit more, -2, 1, 3, so we've got our x-intercepts there. It's less than 0 down here, so negative infinity to -2, so it's below the axis here, so it's coming up, oops, coming up, going down, coming back up. That's what it looks like. So that's all the sign diagram's telling us. Is it below the axis, is it above? And whereabouts? It's above and below. Some people like them, some people don't. But they're mentioned, so we need to look at them. Yes, Brian.
So in the exam, will they tell you to like draw a sign diagram?
They may,
Even if you don't want to.
even if you don't want to, yes, they may. Or they may, you may have one in a multiple choice question or something.
Well, what information would they expect you to write?
Technically, you don't have to, but you're not going to.
If it's specifically asked for, you have to do it. Otherwise, you don't get all the
So
marks.
what
But if it's not,
what information are they going to give you to draw one? Like if they're like, draw a sign diagram, what would they give you? Would they give you an equation or?
If they gave you a graph,
they could give you an equation, they could give you a graph. Either of those. So this next, I'm going to do an example of one. So I'm going to draw a sign diagram for a particular function, so you could be given a function. So this particular function is this. Alright, so you would then need to factorise this, and I don't spend the time doing that. But when you factorise this, you get x plus 3 x minus 2
Yes, it's got some more.
and x minus 5. When you factorise it. Alright. So from this we can get a sign diagram. Alright, what are our intercepts? Negative 3.
2 and 5.
2 and 5. So negative 3, 2 and 5. We know it's cubic. So the question is, down the left-hand end, does it start above or below?
Below.
Below. Because?
It's positive.
Positive, yeah. It's all positives there, isn't it? So it's positive. So it's a normal, like the one that was here, it's a normal start at the bottom left, finish at the top right. So if we're starting at the bottom left, it's got to be below the axis then. Linear factor. So linear factor, so it cuts through. Linear factor cuts through. Linear factor cuts through. Alright, so that's all there is to it. Don't really see the point myself, but that's just me.
You don't see it?
Oh, I see it, but I don't know what the point of it is, to be honest. Why don't you just sketch the graph? I don't know. But anyway, that's just me. But they're mentioned, so we need to do them. Now, if there's a repeated factor, how do you reckon you're going to show a repeated factor? So say like this, for example.
Will it still stand for?
So we've got a repeated factor here. How can we show that, do you think? So minus 2 and 3. Any ideas?
This is straight line.
Straight line. And how do we show this?
The dot.
Yeah, or a line up there or something like that. Because this particular graph goes like this. let's do an example. Not with sign diagrams, so I've done enough examples with sign diagrams.
Jack Finlay.
Yeah, yeah. All right. Solution. Now, part A here, it says sketch using calculator to find the turning points. So if you're using your calculator to find your turning points, you might as well use your calculator to find the rest of your stuff as well. So, how do we find our Y-intercept? X equals 0, and when we put f of 0, you shouldn't need to use your calculator for this one.
Minus 30.
Minus 30. X-intercepts. Y equals 0. So you got 0 equals negative x cubed plus 19x minus 30. And you would use what function on your calculator?
Solve.
Solve, yep.
Good guess.
Alright. So exam 2, something like this in exam 2. So when you do that, you find there's 3 values of x. One of them is negative 5, one of them is 2, and the other one is 3. All right. Finding our turning points on the calculator. A couple of different ways we could do it. What is one of those ways we could do it?
On the calculator? Did you say on the calculator?
On the calculator to find turning points. This is a cubic, so it's going to do some wiggly stuff. All right, so it's going to wiggle. Actually, it's an upside down one, so it should go that way. Whoops, it's cubic, not a quarter. How am I going to find these points?
Maximum, minimum.
Maximum and minimum. You could sketch it and do a maximum and a minimum. Maximum and a minimum. That's one way you could do it. Now you need to sometimes, so the turning points. So one way on your calculator. So one thing you can do is sketch and find our max and min on our sketch. Now when you do that, you will get 1 point, that's negative 2.517, and negative 61.877. And on the exam they will always tell you how many decimal places that they want if you're doing this. Always. I've never seen a question where they don't. And 1.877. So if you are sketching to find your max and your min, you may have to resize your, this one here is at negative 61, so you might have to resize your screen. It's often the calculator, if something's not actually showing on the screen, it doesn't like it. Alright, so let's put in what we've got. Alright, 5, 2, 3, it's probably not the right spot, 2 there. We've got an intercept at negative something or other, negative 30 down there. Alright. Turning point, negative 2.5 something and negative 61, that's down here. So negative 2.517, negative 61.877. And we've got another one, 2.5 and 1.8, so that's about there. Like so. And where are we going to start?
From the left.
Yeah, on the left,
What's
up
negative, so
or down?
Up.
Up, because it's negative, yeah. And then when you think about it, it's the only way, because you've got 3 factors here, it's got to cut through. That's the only way it's going to get to this turning point,
Yeah.
is if it starts up here, isn't it?
Yeah.
So either of those things. There you go, look at that. Isn't that nice?
Should have had a line best bit.
Beautiful, isn't it? I should have been an artist, really.
Looks like connect the dots.
Well, it is connect the dots, isn't it? Once you've got your points, you just connect it up. So that 3-year-old could probably do a better job than I've done. But anyway. All right, the next bit. What's this? So, y equals a half f x minus 1. So now we think about what happens here. So with this translation, we start with our x and y's, what happens? So what does this here do? This
Violation?
Sorry, what?
is a translation
Wait, sorry, I thought you were
Left.
pointing at the half.
to the
No, because
Left,
left,
negative x direction. Okay, no,
Negative x-
positive x direction.
positive x direction.
it's
Yes. So we've got a translation right.
And then it's just F.
All right, so we're translating it right. So if our original x and then we're translating it to the right, our image
Plus one.
+1, x +1, move to the right. Okay, what does this half do?
That's
The dilation in which, from which axis? X,
What?
half from the x-axis.
It would be, if it was in the y-axis, it would be inside.
It would be inside, yes.
Are you sure?
Yes.
Yeah. I think
So here we've done, this f is our function. So we've, blah, 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 we've done our function
so. Hero, flavor, here.
on that table in the middle over there.
Too sharp.
Right, so fx means we've done our function first. So we've done our function. So let's say our function is x squared. So f of x is x squared. So we've done our x squared first, and then we're doing a half of that, which is a half x squared. So x squared is like this. Half x squared is
X quarter.
wider or thinner?
Wider?
Wider.
Yeah.
Oh.
So this point here is moved to there,
yes.
this point moved there.
Ah, yes.
Right, so it's the y. Alright, so yes, if it's outside the function, it's from the x-axis. If it's in here, then it's from the y-axis. Alright, so if it's changing the y value, our new y value is
Y over 2?
y over 2 or a half. So what we can do is we can apply those transformations to these points. Alright, so let's look at our intercepts. First of all, so our y-intercept originally x equals 0. So originally our original is at 0 and -30. So what's our new one going to be? Yeah, but there's a change here as well. So that point there gets translated to 1 and -15. So our y-intercept's a little bit more tricky to figure that out. Because our y-intercept from our original point, so that we can have that translation, we need to be using x equals -1, so that will then translate to 0. Yes?
Yes.
Yes. So when you do that, because I've prepared one earlier, you get -48.
Why do you get -48?
Because I've prepared it earlier.
For like,
If I put -1 into that original function,
The negative x cubed plus 19x to 30.
But why is that now the turning point?
it's not the
Oh,
turning
I
point,
get
it's
it.
the y-intercept.
Yeah,
Because our original y-intercept was -30, 0 and -30, but we've got a translation to the right. So this, our original one's now moved across 1, and then of course the y value is half. So if it's moved across 1, we need to think about, on this, because it's moving across, we're looking at actually this point here, wherever this point here might be. But we're looking at that moving across 1 to now be the Y-intercept. So because we're moving across 1, we say, all right, so the point that was negative 148 is going to be moved across, dilated, and that's going to be our new intercept. And then plus,
It's half of 48,
right,
No, it's
so if you put that in, you get negative 48, so negative 24. All right, x-intercepts, they're pretty easy to figure out.
but Y goes up.
Yeah, but what's a half a 0, Ben?
Oh, sorry, yeah, sorry, yeah, I don't know.
Yep, so actually, so yeah, your dilation's from the x-axis, these things are on the x-axis,
So you can't, they don't change.
so they don't change, yeah. All right, so we had negative 5 and 0, and that becomes negative 4 and 0. We had 2 and 0, that becomes 3 and 0. We had, what was the other one? 3 and 0, and that becomes 4 and 0. And then we've got to do our turning points. Put that here. Let's get rid of that graph so we're not confused. All right. So here's our turning points. So what happens to the x values here? Add 1. Maybe 1.517. 3.517. What happens to the y? Halves, yes. So when you halve it, you get maybe 30 point, because I've prepared it earlier, 939. And the other one is 0.939. To 3 decimal places. And then we can, oops, that's all right. Then we can sketch. All right, so intercepts, so negative 4, there's negative 4, that'll do. 3 and 4, that'll do. Negative 24's there. So we've got that. Turning points, negative 1.5 and negative 30, that's about down there somewhere. And then the other one, oh, it's just here.
This would be a long question.
And so we've got that as our transformed. All right. Yeah, it is a long question, so it would be an exam 2 question.
With calculator.
With the calculator, yeah. Yeah. All right. So that's it for cubics, exercise 4B questions. What have we got? Don't forget, like and subscribe.
I'll put names on it.
the names on it.